So let me share my screen. Please let me know if you can see the screen.
It's visible.
Okay. Can you see me writing? Is the font size fine?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So let's discuss about what this thing is. We have heard about lots of terms, big data, Hadoop, these, that. So when I say data science, it is, and we also say something called business analytics. So data science can be thought about that this is the overall subject, and its application in the business is called business analytics. So what is data science? Data science is a method in which we try to create actionable insights from the data. Any data that we have, from that, our major goal will be to create actionable insight, something that people can work on. Now, data can be of different types. Data can be of, let's say, the data sources are different. Data can come from surveys, data can come from secondary information, reports, annual reports of companies, let's say, or data can come from experiments that we do. Let's say the data is being collected about the COVID patients, whoever has COVID or not, their personal information, their body's information, probably the nasal tab, whatever is collected, whatever specimen is collected, what kind of specimen you get out of that. Everything that is stored somewhere, that is also a data. Data can be pictures, data can be videos also. For example, let's say the pictures that is taken by the GIS systems, or the data that is taken, the pictures that is taken by satellites are also data. So different form of data is there, and we try to create a insight out of it. So that will be the example of data science. Now let me pick it up, and I will try. I generally, when I teach, I try to find out some certain similar kind of situations, and we try to relate with that situation. So I will start with Mr. Shaikat. Shaikat, are you there? Can you hear me?
Yeah, hi, Salvatore sir. I am there.
Yeah, hi. Shaikat, where do you work?
So I am basically into clinical research, and this is a field whereby we try to, test the drugs before it is coming into the industry, not industry, market. So the automation and ML is largely used, but it's in initial phase of the whole industry. So it's basically, to understand more on how we can use that in our current role and others, other perspectives.
Okay, fair enough. Shaikat, are you married?
Yeah, I am.
You're married, right? And you are based out of?
I am based in Bangalore, but now due to the current pandemic situation, we are all working from home. So I am in now Dakhineshwar, just beside Uttarpara.
Okay. So let's assume things get settled and you go back to Bangalore. Let's assume, okay. And how many years of experience do you have, Shaikat?
It's around 12 years. 12, approximately 11 to 12.
Yeah. 12 years. Okay. So you have been working for last 12 years and you have been serious about your career. You have done a lot of work. So and you have been there, let's say, for that you will be settling in Bangalore only. So once the COVID gets settled and people come back, probably your company will ask you to come back, and you are sure that you will be settling in that city itself. And given that kind of, I'm talking about a hypothetical situation, okay? So given that, let's say you decided that you will buy an apartment. Have you bought an apartment, Shaikat, there?
Yeah.
Okay, very good. So let's assume that time when you have bought an apartment and you are so the apartment is almost ready. It is not absolutely ready, it is almost ready. That means the lighting, everything is not lighting. The all the electrical work has been done and etc. But some woodworks has to be done. So you have not shifted yet. So you and your wife visited that apartment, and you to plan that how we will decor the house and etc. So all of a sudden, your wife says that, you see, Saikat, I'm just again a hypothetical situation. Please don't take otherwise. So your wife says that, Saikat, you have been busy for the last 12 years. You have been working for the last 12 years. We are married for the last 10 years, but you are more married to your work in the last 12 years. You have not taken very good care of me. I'm not very happy with you. So you all of a sudden start feeling that no, she is probably telling right. I should take care of her. So you ask her that, you tell me what I have to do. I am very sorry that I have not taken care of you, but everything that I do is basically for you only. So you tell me that what you require. So your wife asks you that, okay, do one thing. In the last 12 years, I have fed you lots of stuff. I have cooked for you very delicious dishes and etc. So today you have to cook one cup of tea for me. So you all of a sudden say that, okay, one cup of tea, that much. Let's go home. We'll make a cup of tea and we'll have together a nice cup of tea. So your wife says, no, I want this cup of tea now at this apartment, which is a vacant apartment. Absolutely nothing is there. Electricity is there, but otherwise nothing is there. And you cannot get the cup of tea ordered from Zomato or Swiggy. You cannot take me to the nearby tea stall and make me or the cafe or make me have a cup of tea. I want the tea being prepared by you in this particular apartment now, which is vacant, and you have 1 hour time in your hand. So what will you do? This is the situation.
I will try to use the online services
No, that's
and
out of question. Zomato, Swiggy is out of question. You have to prepare the cup of tea for her.
the first thing is that I will try to buy, tea leaves.
Okay,
And
what
just,
will you buy? Wait a minute. Let's write it down. What will you buy? Tea leaves?
yeah,
Okay.
a bottle of Bisleri water.
Bottle of Bisleri water. Very good.
Induction.
Induction will be too costly for a cup of tea. Let's buy a electric kettle.
That's true. Yeah, agree.
See, I am saving money for you. Electric kettle. Anything else?
A cup, obviously 2 cups.
2 cups. Okay. What kind of cups? Paper cups?
Yeah, that will do. That's fine.
Your wife is angry with you.
Okay. That is going to be a better one.
Okay. 2 good-looking cups. Anything else?
Apart from that, I think if she doesn't want a raw tea, then it's milk.
Like that?
Okay. Yeah, that's all.
Good. Good that you have told this. Now tell me, how much tea leaves will be required for 2 cups of tea?
2 tablespoons, not more than that.
Will you be able to buy 2 tablespoons of tea leaves?
No, obviously not.
How much will you buy?
50 gram.
50 gram. Where will you keep the rest?
Yeah, for that I need to have a plastic, or maybe the one which they have given. I will try to have it a rubber band and just package it.
Okay, so let's do it a little bit better way. You will have a plastic probably container where we will keep it. Bisleri water. The Bisleri itself has the container, so don't worry. Electric kettle is fine. Where will you keep the sugar? You will require two tablespoons of sugar. You will not be able to buy 2 tablespoons of sugar, right? How much is the minimum? So you have to keep it somewhere. Where will you keep it?
Same plastic container.
Again, another plastic container. Okay. And milk?
Yes, that's true. If it's going to be a half-liter milk, then again I need to have some kettle or something of that sort.
Okay, some content. Some I will, let's say I am writing a glass bottle or something like that. Okay. Now in your home, generally, Why do you put these plastic containers? In cupboard. And the milk bottle, glass bottle of milk?
That's going to be the freeze.
In the fridge. Very good. And in your house, why do you put the cupboard?
In the kitchen.
In the kitchen. And where do you put the fridge?
That's too is going to be the kitchen.
Okay, it can be the kitchen. If kitchen does not have that much space, then nearby to the kitchen at least. Right? This is somewhere you put. So let me now tell me that is this part, this collecting and buying and storing it well, is this part constitutes the cooking of the tea, preparation of a tea? A person who prepares a tea, should he be expert in this part, the purchasing part and storing part?
No, indirectly correlated, but it's not required actually.
Not required. Very well. So this is the first step of data science, where we collect the raw materials, which is the raw data. Then we store the raw data somewhere. And then we store those things somewhere. And then we again store those things somewhere. Where do we store the raw material? The raw material is our raw data. Where do we store our raw data? We store our raw data in, let's say, a Excel file or a CSV file or a JPG file or a doc file, depending on what kind of data it is. For example, you have put a glass bottle or plastic container and etc., depending on what kind of product it is. Similarly, I have different kind of storage facilities where I store the data. Then these Excel files, JPG files, doc files, etc., or at least the tables, if I call it, these tables, I store it in a bigger storage, a box kind of storage, which we call as database. What does this storage has? This storage has multiple plastic containers. Your cupboard does not have only one container, but many plastic containers. Your fridge has many plastic containers, aluminum containers, glass containers, everything together. So when you create a database, it also has different type. It can be a table inside. Generally, database have tables, but there are non-tabular kind of databases as well. So you will put these data sets inside a database. And then you put these databases where you put your cupboard in kitchen. I don't know whether you guys have it. I'm telling to everybody whether you guys have it, but at our time in older days, when the houses used to be big and probably in a rural area or even an urban area, if you are a good well-to-do person, then you will have a storage room. Inside the storage room, people used to have lots of different kind of cupboards and etc. So one kitchen and one storage room separately. So to keep these cupboards, multiple cupboards. Kitchen, you cannot keep multiple cupboards. You will probably, if you have a very big kitchen, you can have probably 3-4 cupboards, which is woodwork basically. But if I need further bigger storage space, then I have to have a separate room. And that is called something we call as data warehouse, where we have further bigger storage spaces. But understand, thank you, Saikat, for playing with means to be such a sport. So, this part is preparation of cooking. This part is not cooking itself. This is where you are taking a preparation of cooking. This part together is called data storage, data collection and storage. Now, data collection can be also done from multiple places. This raw data that I told, this can be done from primary data and secondary data. What is primary data? Anybody in the class? Raise your hand.
from surveys, the data that is collected from surveys.
Yeah. So please raise your hand from the next time. Okay. So yes. So the data that is collected from survey or some for yeah. So I got anything you want to add?
No, just the same. It's the raw
Yeah.
data which
So
we are
it might
talking
not be always survey. The data that you are collecting for the very purpose of for which the data will be used. Then it is primary data. For example, the data that you were collecting to test whether this patient is COVID positive or not is also primary data. It's not a survey data. So not always it has to be a survey data. Primary data means the data that is being collected will be used for the same purpose for which it is being collected. Secondary data is where the data is being collected by somebody else for some other purpose and you are using it. For example, let's say GDP data. GDP data government is collecting to measure that how whether the economy is increasing or not. Now you are probably doing that using that in your research work for whatever reasons. So that is a secondary data. And data sources can be of yeah, Sunil.
Sir, secondary data, can we call them as a supporting data for the primary data?
Not necessarily. Not necessarily. Means
Okay.
sometimes it helps, but
Yeah.
not always it has to support.
Okay.
Okay. So these are my raw data. Now, anybody in this class have seen Big Bang Theory? No, sorry, not Big Bang Theory, Friends. Anybody have seen Friends?
Yes, sir.
Anindita, have you, do you remember Monica has, how was Monica? Did you remember Monica?
Yes, sir. So she has OCD.
She had OCD. And did she have some place where she could manage her OCD by stuffing everything in one room? Did she have a secret room?
I think so, sir.
You don't remember?
No, sir.
Okay, syllabus incomplete. Anybody, anybody who remembers, who have seen Friends? Okay, so if you have not seen, doesn't matter. So I generally use this one. Monica was a role which comes under this Friends, which is a very popular sitcom. And Monica is a person who likes to host everybody, who is a very beautiful host. And she also has some, she is basically cleanliness freak. She is very particular about cleanliness. But she had a room also, which nobody used to know what is there in the opposite side of the door. And one day his boyfriend and later husband has opened the door and found out that, okay, there was lots of stuff which were just kept. I was very dirty in my college days. And I used to remember, and this kind of memes also comes out today, that you have a heap of dresses on your hostel room's bed, and you pick up that in the daytime. You basically pick up that huge heap from the from your table or chair, whatever has been given to you, and you put it on the bed and then work on the table. And in the evening time, you again put that up from the bed, or sometimes you just uh, push it a little bit and then you lie down beside that. My mom used to say that even if you try to find out an elephant inside that heap, you will get it. So I used to answer that even if you keep an elephant inside that particular heap, it will get lost. So that kind of a data storage, that kind of a storage space where everything can be found and everything can be lost, is something called a data lake, which is currently coming up. So remember this. I try to give these things so that you remember with the story. I remember with this story that I used to have such kind of a heap. I think many of you will have. So that is called data lake. What is data lake? Data lake is that data warehouse. In data warehouse, all the data is stored in a tabular form, in a particular well-maintained form. These are all mostly textual data. And it might be some doc data and etc., but still they have a particular I would say spreadsheet kind of a format. The advantage of data warehouse, I will come to you sort of just 1 minute. The advantage of data warehouse is that it's easy to get data from that. It's easy to query. If you ask, there's a tabular form, and if you ask for a data, it is easy to search in that particular tabular form and get you the data. However, there are certain kind of data which is not required every day, which is not required in a very high speed. That means whenever the data is sought, you can wait for 5 minutes, 10 minutes to retrieve the data. But storing the data is very important. It has to be huge amount of data that has to be stored. For example, let's say in your bank, your signature. The bank stores your KYC data, your picture, your signature. Not every day it is required. Every day your balance is required. Every day the transactions that you are making, those data is required. Those data are stored in data warehouse. But there are certain data points which is not required. For example, that one that I told, these are picture data, right? You cannot discard them, but you cannot store them in a readily available format. You have to change it in certain format and keep it in somewhere where it will be difficult to retrieve. You can only probably send there's an upper limit of how much speed you can how much speed you can retrieve the data. But it is very important to store the data. You cannot lose it. So those kind of data, when they are stored, these concepts of data lake is coming up into this world, where data is being stored in a certain format, which can be lots of data of different formats, whether it is doc file, JPG file, video file, this file, that file can be stored and can be retrieved at a lower speed, but can be retrieved. It can be collected. So that's also one kind of data storage. Again, it's not part of cooking, it's just a storing. Yes, Saurav, you have asked some question. Chitrakar.
No, sir. I just wanted to share that basically, as per my knowledge, basically we store structured data in data warehouse and mostly structure as well as unstructured and all kind of data in data lake. That is what my understanding. So
yes, that's an absolutely correct understanding. However, it's not only the structured and unstructured part is the question. It is also the question of the retrieving ability. Means whether, let's say, structure can be put in both of them. Will you put it in data lake or will you put it in a data warehouse? It has to be, if you need the data very frequently. For example, machine level data in a production process, the machines whether the machine is working well, that kind of data, sensor data that we call. That's a structured data. We don't put it in data warehouse. Why? Because that is not required. Why will I bog down my data warehouse, which is located probably at a more accessible position? Let's say it's like boxes. Will you put the boxes of unnecessary items in close by to your bedroom? In the bedroom, you will put boxes where the necessary items are there. And in your storage room, back of the balcony, somewhere, you will put the unnecessary items, even if they are boxed. Same thing applies here.
okay, thank you.
Okay. Yes, so let's go ahead. So now I will again come back to Shoikat. Shoikat, have you helped at any point of time? Can you cook, Shoikat?
Yeah, I saw that. Yeah, I can.
Okay, so have you ever helped from whom did you learn cooking?
It was me myself actually. I tried it, all types of stuff, whatever I could, looking at the YouTube or.
So your mom didn't teach you anything, or at least encouraged you?
Actually, no, never.
Okay.
Always pampering. So whenever you are in home, she will not let you cook.
Okay, so then this example will not suit for you. But anyways, let's say your mom is trying to teach you cooking for the first time. She knows that you will go out, you have to cook on your own. So she is trying to give you some basic funda initially. So my question is that, what will a mother ask her son or daughter to do for the first time when they are starting cooking or starting to help the mother in the cooking process? What kind of job the mother will give to the kids?
First, she will ask the rice to get cooked, or she will ask them to make khichdi. I think,
Okay.
and
Yeah,
then cut
Sunil,
vegetables.
Sunil raised your hand. Sunil, anything you want to add?
Yeah, I think first will be always cutting the vegetables or making utensils or something.
Great. Shuman?
So first thing would be the cleaning of the fruits or vegetables, cleaning of the rice, like this thing.
So cleaning, cutting, these kind of works will be given to the persons who are just learning to do cooking, right? So this second part is the same thing here. It's data cleaning and data cutting. Let's talk about that. So I have studied in a missionary school, which is this Narendrapur Ramakrishna Mission, which is basically a missionary school under the belief system of Ramakrishna Paramahansadeva, which was made by the school was prepared, or the ashram was started by Vivekananda. So there was a yearly event called Naranarayan Seva. So what is Naranarayan Seva? So Narendrapur has lots of villages, and there are Hindu villages, Muslim villages in and around the campus. And all the people were invited in and around that particular campus, Hindu, Muslim, irrespective of their religion. On that particular day, they can have their food basically on the campus. So there will be around 20-30,000 people of different religion, different age, different gender will come to the ashram for that particular event. So we had our duties. We residents, we were students, we had our duties. So my duty, I remember very fondly one particular thing. My duty was, there was a heap of chili. Okay, so let's say this is a heap of chili. My duty was to pick up one chili, break the head of the chili, put the head at one point, and put the beheaded chili at another heap. And not only me, there were 10 other people who were doing the process. Picking up, breaking the head, putting the head one place, and putting the chili in another place. This has a specific name in the context of data analysis. So this is also data cleaning, and whatever your mom used to ask you to do is also data cleaning and etc. But this has a process of data cleaning. The process was picking up, which we call as extraction, extract the chili, transform the chili from with head to beheaded chili, and then load the beheaded chili somewhere. Extraction, transformation, load. ETL, this is a term that is used in data processing very commonly. So the next process is data processing, which is basically data cleaning. And one of the method of data cleaning is called ETL, which is extraction, transformation, and loading. You extract the data, you transform the data as per your requirement, and you load it back to the data warehouse or database again. So this is a process. Now, I just now told that I alone was not doing. There were 10 other students who are doing the same job, exactly same job. That is called parallel processing. So there were 10 people who are parallelly doing the same job. Sometimes it is possible, let's say in your computer, if there are multiple nodes available, I will not go into the technical details. If basically if the brain can compartmentalize itself into 4 or 5 different brains, picking up the data and breaking the data and storing the data does not require lots of knowledge. But it's probably a 10 standard person, or forget about 10 standard person. This particular job probably even a 5-year class 5 student can do. But can you break one person to one full grown person to 5 class students kind of a breaking? Can you do that? If you can do that, if you can break one person into 5 students who are of 5th standard and then put them in the data making process that is called parallel processing. Nowadays, in the computer, we have multiple nodes. We can do it. When you do it in a larger volume for using a server to a bigger data set, that's called parallel processing. These are ETL and parallel processing are generally used when the data storage are high. When the data is small, you can do it yourself using Python or R, which probably Gaurav will show you. Okay. Now, till this point, it is also not cooking. It is data collection, data storage, and data processing. Okay, fair enough. It's preparation of the cooking. Now, these things together, this is one part of business analytics, basically. These things together is called data engineering. So, and it also when data this data collection, storage, and processing, these things together is called data engineering. And a person who gives a framework to this activity is called a data architect. So they give a framework. The framework means what kind of database will be used. They don't say that what will be the ETL process, but they say that what kind of database will be used, which data will be processed and then stored in which database, so that least amount of time is required, least amount of processing time is required. So that is data architecture, and data engineering is this procedure. The question in this particular case is that who can do that? What kind of I would say requirement, what kind of people can basically do this activity? So for this, you need generally, let's say, people who have CSE or MCA background, or let's say even BTech people in IT can do it. BTech and tech people in IT can do it. They are trained to do this job. Other BTechs are also trained in this kind of areas to do this job. But you do not require statistical analysis, statistics specifically, to do this job. Now let's come about another part. Soikath has made his cup of tea, and he has bought two beautiful cups of tea, beautiful cups to serve it. Why did you buy, Soikath, two beautiful cups?
That's to represent in a better way.
Representation. Soikath, did you buy only two cups? Did you buy anything else?
No, I think it was cost effective. Only 2 cups.
Only 2 cups. You could have bought some cookies with the cup of tea, or something. Will you buy some cookies also?
Most probably, maybe.
Most probably. Why will you buy?
Just to make it more representative,
Oh, representative.
beautiful.
So more there has to be some accompaniments with it. You will buy. So that is also, the cooking is one part of the story. The I would say the presentation of the cooking or the food is very important. If you see the Master Chef, you will see that in Master Chef episodes, people give huge amount of importance on how the food was demonstrated in the plate. It's presented in the plate, and there are marks for that. So that part is called, basically, in our context, is called data visualization. Data visualization. Now, data visualization has multiple ways. So it can be like old school MIS reports or your Excel dashboards. Even these are data visualizations. Nowadays, we have brought in a little bit of dynamicity, little bit of extra in this data visualization, the cookies part, which is called dynamic dashboards. So dynamic dashboards are done using certain tools. For example, you will know Tableau or ClickView or Power BI. Power BI is something that is given by Microsoft, or in the context of R programming, something called Shiny Server. So these are some of the examples of dynamic dashboards, which are presentations that are also being done and which is also part of. But see, the difference is this is also not cooking. The chef will also, although the chef will focus on the presentation, the ultimate, I would say, ultimate evaluation of a chef will be not being done based on the presentation alone. So a chef should know this. A chef should know the raw material storage part also, buying part also. A chef should know a little bit of data visualization also, but that is not the key activity of a chef. So who can do it? Anybody who has certain kind of aesthetic sense and business sense can do it. We see any graduate, majorly people focus on business graduates or economics graduates and engineers. However, any graduate who have a little bit of common sense can basically do this activity. But in between these two comes data analytics, which is a bridge between the preparation of food and presentation of food. Data analytics is cooking of food. Now let me come to you. Once more, let me find out if there anybody else. Just 1 minute. Okay, Preeti Nilanjana, are you there?
Yes, sir.
Yeah. So Preeti, I have some questions for you. Will you be game to answer?
Yes.
Okay, Preeti. Preeti, let's assume that you are facing some fever. Okay, not in a non-COVID world. You are facing some fever. Okay. So there's no COVID, so the doctor is not asking you to go to do some tests, but you have been facing fever for the last 3 days. You have taken medicine, paracetamol. The fever came and went away, again came and went away. After 3 days of these things, you went to the doctor. It's a OPD. OPD means outpatient's place. You waited in the waiting area and your turn came. The doctor asked, or the compounder basically asked your name, and you opened the door and came into the room. Doctor asked you to sit down. Then what will happen next? Can you complete the story? What will be the next steps that are going to happen then?
The doctor will ask that days you are having fever, then I will tell about symptoms, what symptoms I'm having. Then he
Okay.
may
Good.
ask to do some test.
So a doctor will ask you certain symptoms. So let's write it down. Symptoms. Will the doctor check your throat and your respiratory system using the stethoscope and etc.? Will that be done? Yes, no?
Yes, sir.
Okay, so doctor will use some physical condition, doctor will check. Question is that then you are saying that doctor will give you some tests. What test will the doctor give? Will he give an x-ray of your leg?
Sir, to do blood test and see if you're having
There
viral fever
are
or
10,000 different types of blood tests. Which one will he give? How will he decide that which one to give, which one not to give?
saying the symptoms, he will decide.
How? Let's say I see a symptom. Let's say your symptom is that the fever comes and goes away, after taking medicine, after taking paracetamol. This is a symptom. Then what test will I give? Will I give a uric acid test or a blood glucose test?
So for like for flu or viral fever.
Yeah, and why will you give a test for viral fever? Why not blood glucose?
Viral fever because as fever is coming and going, so it may be viral.
Okay, okay. Anindya, you wanted to add anything? You raised your hand.
Sir.
Yeah, Anindya, I cannot hear you.
No, sir.
Okay. Anybody else? Sunil, yes.
So basically, to rule out the viral infection or something, or the microorganism infection, maybe
And why will
typhoid.
he not? Why will he or she not focus on possible leg fracture? Why do you think that he has to rule out viral fever and not leg fracture?
So leg fracture and the fever is nowhere related. So that's the first thing.
So what are the related things that you think fever is related to what?
Okay, so when they ask for the symptoms, maybe the vomiting or raise in temperature and reduction in the temperature, or tiring, or even cough, cold.
So let's say
all
these
of-
symptoms. These
Yeah.
symptoms are related to what?
related to fever.
No, these are all fever is also a symptom.
Yeah.
I'm saying these symptoms are related to what kind of physical condition, physical ailments. You told viral infection is one possible thing. Anything else?
Maybe food poisoning or something.
Okay, food poisoning.
Food
Suja,
poisoning.
anything you want to add?
The same food poisoning I was telling.
Okay. Let's say some other thing. X, Y, Z, I don't know. Some things that the doctor will think in his mind and he will try to rule it out.
Yeah.
So in our terms, in statisticians or data analytics terms, these symptoms and physical condition measuring of that is called descriptive analytics. This is basically describing your situation. It's called descriptive analytics. And then you are trying to diagnose why this has happened. And these are the possible reasons. Possible reasons. Or we call it, these are the possible hypotheses. And we do these different kind of tests. It can be blood test and this test and that test to test which of these hypotheses is correct. I'm making a hypothesis, an assumption that this has happened because of viral infection, and I try to test whether that is correct or not. Why I'm testing that? To diagnose the problem, and that's why it is called diagnostic analytics. The next step. So the first step is descriptive analytics. Then we do diagnostic analytics. And how do we do diagnostic analytics? Using hypothesis testing. So we create hypothesis in our mind and we try to test it in different ways. Then once this is done, once this diagnosing is done, let's say I know that you have viral infection. Viral infection, for that, I personally know about 3 medicines: ABCD, EFGH, and IJKL. Which one will I give it to you? Which one will be prescribed?
Depending on the phase of infection, maybe it's just a guessing, I guess, that primary antibiotic should be given first.
Let's say all these 3 are primary antibiotic. Which one will you give?
Mm,
Shoikat?
EFGH.
Looking at the historical data, what will be the likelihood of which medicine is more effective?
Thank you. So I will give that medicine. I will, what he told, I'm just writing down. I will give that medicine which is most effective. And how will I know? Looking at the historical data. So based on the historical data, I will give that medicine which is most effective. Now I do not know what will be the effectiveness. That's a prediction that this, if I give ABCD over EFGH and IJKL, instead of giving EFGH and IJKL, if I give ABCD, I am predicting that it will be the most effective. I do not know. And how I am predicting? Based on my historical data. It has been given to many other people. Out of so many people have been done well. That's what you do in lab tests and etc. You test it out. You do not know. You try out and test it out at which particular formulation will work. So that is called predictive analytics. However, is it enough? Let's say a person has cancer. Let's say. So there is an oral chemotherapy that can be done, oral medicine basically. There can be radiation can be done. There can be, let's say, certain surgery can be done. Alternative medicine can be done. Alternative medicine means Ayurvedic and this and that. And palliative care can be done. Which one will a doctor choose and how? Anybody? Will the doctor choose only based on the effectiveness? What will be the, yeah, Keshav?
So it would also depend on the stage of the cancer which the patient has.
Why?
So because if it's a first stage cancer, then it might be possible the medication, through oral medication, the treatment can be done. Whereas,
so then you are talking about effectiveness, right?
Right, sir.
So you will be trying to, you will be trying to maximize the effectiveness. Whichever method gives you highest effectiveness, you will choose that.
Right, sir.
I'm asking you that other than the effectiveness, anything else may matter.
So
Yes.
along with that, the historical data would also matter.
Historical of what?
Of again the effectiveness.
So I'm effectiveness I understood. Anything else that should matter? Smita?
Sir, we have to see what is the condition of the patient. Like, will the patient be able to take it? Because
will he or she be able to take it? Anything else that should matter? Mala?
Can he afford it?
Afford it. Can he afford it? Or in single word, we call it budget constraint. And this is a physical constraint. Can he take it? Physical ability or whatever constraint. Okay, somebody sent a message. Can hospital has the facility? Very good. Whether the hospital has the facility, which is okay, hospital
capacity constraint. Capacity.
Not only capacity. Okay, yeah, capacity constraint. Whether hospital has the capacity. Capacity can be dependent on whether hospital have enough beds or ability to do that. Both kind of constraint. Anything else? Mala, you want to add anything? Okay, so what this part thing will be doing, this cancer doctor This will be basically, he will be maximizing well-being of the patient over this choice, over these constraints. And based on that, the doctor will suggest. It can also be that whether the person has a caretaker in the family, or whether the hospital is nearby, distance constraint, and blah, blah, blah. So there can be so many different kind of constraints. Based on all those constraints and based on all the possible options, the doctor will take the best possible option, which will maximize the well-being. So here, what I'm trying to do is maximizing an objective function over various decision variables, which is what to choose, and various constraints. This is the activity that I'm trying to do. Maximize an objective function, which is well-being in this context, over different decision variables. And these decision variables are basically coming from this effectiveness, which is predictive analytics. I'm using this predictive analysis, but that is what I'm not stopping. I'm using the predictive analytics in a prescriptive analytics problem, in a prescription, how I will write my prescription in that problem. That is called prescriptive analytics. How do we cover this? We cover this using certain kind of optimization techniques. So this is what is data analytics. We will be trying to focus on this part majorly in this course. We'll not focus on this. We'll not focus on these also. We will, this particular course is on data analytics, on the cooking itself, on the doctor's job itself, and this is what we are doing. We are not doing the nurse's job of preparing the patient, or we are not doing the frontline person's job of making the patient feel good. We are doing the doctor's job, the middle four part. Okay, now let me go ahead one more step. So till now, any question? I will stop here. Did you understand that what are the broad domains of? Okay. Now let's talk a little bit more on predictive analytics. Because why? Because predictive analytics is one of the most important analytics technique that is being used in today's world. Now, when I talk about predictive analytics, there are two schools of thoughts that comes into the picture. Predictive analytics, what it does, it tries to predict something. What it tries to predict based on the past data. So it has a X variable, some X variables, some independent variables, based on which you predict a dependent variable. Now, predictive analytics has two schools of thought. One is a econometric school of thought, and another is a machine learning school of thought. And these two schools quarrel with each other. For example, in our department also, there are professors who are very, I would say, strong in machine learning. And they have probably, they work in machine learning techniques and they work with Python. And there are other professors who have come from an economics background, let's say. And their major focus is on the econometric techniques. What is econometric technique? Econometric technique focus, and this even in our department also, these two groups of professors, or rather two professors, quarrel with each other on whose method is good and whose method is bad. You will know as you more talk with people. So what is the econometrician's thinking process? Econometricians think that, okay, X leads to Y. This is something that both of these schools of thoughts people are saying. But here, the most important part, the focus point, is this. And here, the focus point is Y. So that is the difference. In a machine learning, correct prediction becomes most important. How you are achieving that prediction is less important. On the other hand, in econometrics, these schools of thought, the correct prediction is important, but not as much as the validity of the relationship. Whether X should predict Y, whether X can predict Y, whether I can take X as a predictor of Y, that validity becomes more important. How X is predicting Y, that process becomes more important rather than the actual prediction of Y. Now, what does that mean? What does that particular thing mean? For example, let's say it has been seen in a particular city or in many cities. This test has been done in USA over many cities. It has been seen that the cities which have more number of waffle stores have more number of divorces, has seen more number of divorces. So people were very angry with the waffle stores, that these waffle stores are there and people are going and meeting other people in that waffle store. And that's why probably all these people who do adultery probably do it in the waffle store. And that's why these divorces are going up. Or probably people are when getting angry with their counterparts or they go to waffle store, and waffle store make them understand that there is an alternative world also. You do not have to be in the married life. You can come and eat waffle, and that's why they are getting divorced. Is there any meaning of that? Can you tell me why waffle store is leading to lots of divorces? More number of waffle store, more number of divorces. Yeah, I will not ask you, Shoykot, anybody else? Ashish, yes.
Sir, is this correlation and causality that you're talking about?
Yes. How can you explain the underlying story of the correlation and causality? Why do you find out a high correlation between waffle store and number of divorces?
It's a little confusing.
Which place has more number of restaurants? Kharagpur or Kolkata?
Definitely Kolkata.
Which place has more number of divorces, Kharagpur or Kolkata?
Kolkata.
Is there a why is happening like that?
More number of population.
More number of population. So basically, waffle store has nothing to do with number of divorces. Probably if they taken per capita waffle store or something like that, things could have changed. But a machine learning guy will not bother about that. Machine learning guy will take that as a variable and predict number of divorces. As long as the prediction is coming well using the methods that they're using, they have no problem. But the econometrics guy will have a problem with it. Econometrics guy will try to find out the population as a variable, even though population is not giving good prediction. It may not always give good prediction, although it is logical. So that is the basic difference between econometrics and machine learning. Now, why does it matter? For example, let's say if I'm trying to predict whether a flight will fly or not, whether an aeroplane will fly or not. An aeroplane will fly or not depends on physics, but the physical systems are not in our control. We use Bernoulli's theorem to fly a aeroplane, but this Bernoulli theorem is also one kind of a I would say some kind of approximation. You do not know exactly what is the air pressure, blah blah blah. Air pressure can change every second. So the physical systems are all the analysis that we're doing is based on approximations and simulations. And using those simulations, we try to predict that whether this particular flight will fly or not. So there is absolutely no econometricians, no econometrics is involved there. It's absolutely machine learning. And we are still believing on that. We exactly do not know why the flight is flying. We have a little bit of idea about Bernoulli's, but believing on that Bernoulli's theorem blindly, every day we are riding a aeroplane, absolutely based on machine learning systems. So what I'm trying to say here is that in many mission critical kind of problems where exactly predicting why is not possible, we use machine learning. But the same thing comes into somebody who's in clinical research. He will absolutely disagree with me in this particular line. They will say that clinical research don't use machine learning. Nowadays in the lab, in the drug design and etc., machine learning is coming in. But historically and even today, it's dependent on econometrics only. You have to tell that why this particular medicine and how this particular medicine is impacting the result. You cannot just tell that, okay, it is giving good prediction, that's why we are going ahead with it. So for a very long time, all these kind of activities where the relationship was more important. For example, if I predict, let's say I am predicting that Gaurav Sharma, my TA Gaurav Sharma, is not a I would say not a person who is credit worthy, but somebody else, let's say T Williams is I have a Williams in the class, Williams is credit worthy, or the vice versa, let's say. And I do not give the explanation. I say that my computer is saying that, that's why I'm doing it. Either Gaurav or Williams can sue me saying that, this person is doing based on religion. You see, this person is a bad person, he is racist, this and that, and he can sue me in the court. Giving that in that thing in mind, in finance, in credit rating, although machine learning gives better prediction that who will default and who will not, in finance, in credit rating, machine learning was not used for a very long time. Let me give another story. Machine learning, if you use machine learning, why the ethical question comes up? If you use machine learning, every person wearing a turban after 9/11, people used to predict that this person can be a terrorist because the face matches. So all the people who are Punjabis from India will be stopped and specially checked in the airports. So that's the problem of machine learning, because it does not use the explainability thing. As long as it is predicting well, it is good. However, it has lots of usage also, lots of advantages also. The one that I just told, that airplane, we cannot handle it with econometric techniques. We do not know the physical systems itself. So that's why we rely on simulations and machine learning. Same applies to drug design problems, how it is helping today. There can be so many different combinations of drugs that are possible. You cannot test all the different combinations. So you have to find out which, let's say 10, 15 combinations, which can give the best result. And then with those 10, 15 combinations, you do laboratory tests and use econometrics. So to get the possible options of the drug designs, people are using machine learning. Am I wrong, Shoikat? Shoikat, you are in LabCorp, right? You are in drug design, you were telling, right?
Yeah.
So is it being used in your case as well?
Yeah, so this is not, I'm not so familiar about that actually. It's a completely different domain I have.
Okay, fair enough. So if you go and talk with people who are working in clinical research or who are working in drug design kind of problems, they will tell you that this is how this group is being used. So when I say econometrics, I'm using these two terms very for quite a long time. What are they? They are basically regression, linear regression, logistic regression, like this. Sorry, just 1 minute. Majorly regression, and machine learning people say that even regression is our group. So they do not believe that regression is something else. So regression and logistic regression is also their people. And there is other techniques as well. For example, there are decision tree, there is artificial neural network, there is k nearest neighbor method, which is the easy method. There is something called random forest. There is something called boosting method. So these are all part of machine learning techniques. We will cover this in our course. We will also cover up to this. Random forest boosting method will not use. Random forest will try. So this is also one part of predictive analytics, one way of breaking it. Another way of breaking predictive analytics is based on the data type. Data type means there are three groups. I'm just openly telling you and you will understand what I'm trying to talk. Let's say you are trying to predict. Yes, Soman, yes, please.
Sir, hello.
Yes.
Sir, you have told that in the finance industry, like in the credit rating, like predictive analytics is not used. But actually, sir, while I was doing some work with the Credit Suisse and NetWest markets, then we were using Monte Carlo simulation for the credit rating analysis. So
Yeah,
that is some part of the predictive analytics which we are using.
Yes, so 10 years back, it would not be used. Nowadays, it is used. Nowadays, all of these things are used in credit rating also.
Okay, yeah, 10 years back, it was not used. Correct, correct. In 2016, 2018, 17, 18, it was almost used. Okay, got it. Thank you.
Anything else? Anybody from anybody else? Okay. Predictive analytics can also be divided into three different groups. One is called cross-sectional. So this depends on the data type basically. When you use cross-sectional data versus time series data versus panel data. Let me tell you what these things are. Cross-sectional data means you have X and Y of multiple people, multiple objects, and of one period. Let me give an example. Let's say you try to predict how my knowledge, my communication, and my delivery, way of delivery, these three things impact satisfaction of the people who are doing this course. Knowledge, communication, way of delivery. So what I do a survey with all these people. I ask them to rate in overall satisfaction, 1 to 5 point scale, one star to 5 star. And then I ask them to rate one star to 5 star communication, 1 star to 5 star delivery, 1 star to 5 star knowledge. I create a table. Each table has, let's say, 36 rows. Each of the students is one row. And let's say 4 columns. One column is my overall satisfaction and 3 other columns. Now, all of these things are taken on today, 30th 4. And I try to predict that how my overall satisfaction, your overall satisfaction, is related to these 3 variables using predictive analytics techniques. So you are multiple objects, 36 different objects are there. 36 different objects means sample, let's say, multiple sample I write. Sample, not sample, sample, what will you call? Sample item or whatever. So you guys, each of you guys, is one sample item. So there are so many different of sample item, but only one period I have collected the data. That is called cross-sectional data. The moment I do the same thing for each of my class, every class at the end of the class, I see that. Let's say I take 10 classes, each of these classes I take that. That becomes a panel data. Why that we do? We try to see in the panel data that the change of your satisfaction score, is it because of my improvement in all these three variables, or is it like you all of a sudden become slowly more lenient towards me, and that's why your score is going up? So is it you who is the reason, or is it me who is the reason of slowly getting the scores up, overall satisfaction up? That's why the panel data will come into the picture. Time series data, on the other hand, have X and Y of one sample item over multiple period. For example, right now, I am working with one firm in their marketing. Okay, I am working with their marketing mix modeling. Marketing mix modeling means they are investing in multiple channels, marketing channels like digital, Google, Facebook, YouTube, these, that. They're doing digital marketing. And I'm trying to see that how those digital marketing is impacting their sales. Now, I have only one company's data. The sample is one. X is their expenditure in different channels. Y is the sales. But I have the data of only one company over last, let's say, 12 years or 10 years. That means multiple time period, but only one company. The same thing if I had for multiple companies, that would have been the panel data. Now, for this particular cross-sectional method, we use all these red ones. This regression, decision tree, neural network, KNN, random forest, all this that I told is generally used for this. So we will cover that in our course. In the full course, module 1 and module 2 together. In module 1, we'll only cover regression. In module 1, we'll only cover this. In module 2, we'll cover all this. In module 2, we will also cover this. So if I have to color code, module 2 is where we totally cover this. Panel data we will not be able to cover in this course. Panel data requires separate 30 hours course. It's tough, and I'm not an expert on that. So I will leave it aside. I will not teach panel data. So this is what we'll cover in module 2. This is what we'll cover in module 1. And also this is what we'll cover in module 1. Okay. Saurabh, you have raised your hand. Please let me know.
Yeah, sir. So I didn't get the panel data portion. So is it possible for you to explain one more time if possible?
So let's say
Okay.
sales and Facebook, LinkedIn, and let's say Twitter. You give advertise in these things. Let's say this is month. And this is year. Let's say 2021. Let's say this is the 2021 data. And there are some figures here. These are your expenditure, the marketing expenditure that you have done on January month, on Facebook, LinkedIn, Twitter, on February month, on Facebook, LinkedIn, Twitter, and this is the sales. Okay. Are you with me? Shuman?
Yes,
sorry,
sir,
Saurabh, sorry. Saurabh. And let's say I also have 2022 data. I do not only have 2021 data, or let's say not 2022, sorry. I also have, just for a minute. Or let's have 12 months data only. I will not go. Yes, sorry for that. Yeah, so this is how many periods are there showed up in this data set.
Yeah, basically, it's 2 years data you're covering, right?
No, I am covering 1 year only, 2021 only.
Oh, sorry. Yeah. Okay. So it's a period to 12 months data is there.
There are 12 months data. Okay.
Yeah.
And this data is of one company. Let's say company name, which is company 1. So this data, all the data is from one company and 12 periods. This is the time series data as of now.
Yes.
Just 1 minute. Sorry. These are all company 1. Okay. So these are time series data. To make it a panel data, I have to have same kind of data set for company 2 also. So company 1's sales and expenditure from January to December, and then company 2's sales and expenditure from January to December. And then probably company 3, company 4, company 5. So multiple company, multiple time period.
I got it, sir. Okay. So
Got it?
basically, yeah, I got it. Basically, it's the mixture of the other two data.
Exactly. It's a mixture of other two.
Yeah, I got it, sir. Thank you very much for
Okay. So this is called panel data. We'll not analyze those kind of data in this course. Okay.
Thank you, sir.
Okay. Okay, so let's stop here. So that's the overall objective of the course. What is data analysis? What is machine learning? There are other terms called deep learning, and artificial intelligence. These are two terms that people discuss about in the context, but I will talk about that in a different class. We are almost 1.5 hours down. So let me give us quick recap of what we discussed. So this is an introduction to data analytics class, and I had to tell you that what is data analytics. Data engineering is not data analytics, collecting data, learning ETL or Hadoop. ETL is where, so to do this, you use the technology called, or framework called Hadoop rather. So Hadoop is not data analytics. The Hadoop training and ETL training and let's say Scala training, this is not learning data analytics. Okay. So Scala, Peak, these are technologies, or basically not technologies, these are Scala, Peak are tools. So you learn that, but that is not data analytics. When I call data warehouse, we get, let's say, data warehouse, not when I call database can be database. If you remember, I compared it with cupboards, right? Now cupboard you can make on your own with wood, which is called MySQL, which is an open source cupboard, and cupboard you can buy from Godrej also, Godrej Interiors, which is basically proprietary cupboards, which example of that will be Oracle. So these are some of the databases. MySQL is free of cost. It's open source. Oracle is this thing. And then you collect raw data from primary, secondary. Oftentimes we see this particular term. I will just quickly use this term here. We get data oftentimes from an ERP system. ERP system full term is Enterprise Resource Processing System. Resource planning, sorry. Enterprise Resource Planning System. One of that Enterprise Resource Planning System, which is very commonly used in industry, is called SAP, which use Oracle database at its background. So SAP is a company's name. ERP is the product's name, the product category. So that is where also people sometimes get data from. So we discussed about all these things a little bit, and we told that this is not data analytics. Also, people get to learn to collect data from the SAP system or any database. You have to learn a language to do this ETL activity, data cleaning activity. You have to learn a language. A basic language that somebody used to learn is SQL. There are many people who work on SQL. That's not data analytics. That's data cleaning. People who are working with Power BI, Shiny, etc. This is very important to learn SQL. This is very important to learn at least one of these things. But you can learn it on your own. You do not require a specialized training for that. So you should learn on your own using Udemy or something. It's not required specialized training. This part is data analytics, which requires statistical knowledge. Here you need computer science and statistics knowledge to do this activity. So we will be doing that in our course. And when I say descriptive diagnostics, I will teach you descriptive analytics, probability, standard deviation, mean, etc., from tomorrow. Diagnostic analysis is also something that we'll be covering tomorrow. We'll covering not tomorrow, in the next week. Predictive analysis also will cover next week. Under predictive analysis, what we'll cover in the module 1, we'll cover regression. We'll also cover logistic regression. We'll also cover logistic regression in module 1. In module 2, we will cover all these machine learning techniques, and we will also cover time series data analysis, forecasting techniques. So that's why I will close this session. If you have any questions, please let me know. Yes, Gaurav.
Yeah, hi. So I want to understand when you've said that all these logistic regression, linear regression, all the machine learning modules are applicable only for the cross-sectional data and maybe not for the time series data. So why did you say that? I mean, because from what I understand, they are applicable for time series data as well.
No, so I'm not saying that they are not applicable for time series data. I'm saying that time series data, you can apply these things only after you take out the time series component from it. So time series, so only when you make it stationary, we call it, means the trend and seasonality component are removed from this, then only you can use this cross-sectional data. So the way they are used in time series analysis, any regression techniques or any machine learning techniques, the way they are used in time series is first, from the time series, the trend and seasonality is removed. After that, what is the error remain? We'll talk about that. Whatever is the remaining, which cannot be measured by trend seasonality component, that is explained by this. So we basically, in common sense, common language term, we make the time series data to a cross-sectional data. That time period part, we remove it and then we use it. So I would not exactly say that they are not used in time series data. Probably that is a wrong way to say that. Yes, it's a wrong way to say that. They are used in time series data.
Okay. From what I understood is, I mean, we just need to have just a single period to apply all these ML and this.
No, it's not. It need not be a single period, actually. The data, the X variables can be of multiple period as well. I should not have said that.
Okay. Many thanks. Yeah.
Okay. Any other question from anybody? Okay, fair enough. So we'll stop here. I will share this Excel for you. You can have a look at a later point of time. 15 minutes down the line, Gaurav will take the session. So we'll come back after 15 minutes.
Sure. Thanks.